If what we see is the interpretation of electrical signals sent to the brain from the retina, is what we perceive as vision more akin to a projection? Consider that what we think we are seeing is actually just the electrical signals the photoreceptors of your retina are sending to your brain to have decoded and interpreted into an image. This is true for all of our senses. The human perception of reality is a fascinating topic that has captivated philosophers and scientists for centuries. In recent years, advances in neuroscience have shed new light on how our brains interpret the world around us. One key insight is that what we see is not a direct representation of reality, but rather a construction based on the electrical signals sent to our brains from our senses. The visual system is perhaps the most studied of our senses, and it provides a great example of how our perception is a construct. The retina, located at the back of our eyes, contains photoreceptor cells that convert light into electrical signals. These signals are then sent to the brain, where they are interpreted into an image. However, this interpretation is not a simple one-to-one mapping of the signals received. Instead, the brain uses previous experiences and stored perceptions as comparisons to interpret the signals into the appropriate image. This process results in a personalized perception of reality. Even if two people are looking at the same object, their individual perceptions may differ based on their unique experiences and perceptions. This is because what we perceive as reality is not just a function of the signals we receive, but also of the way our brains interpret those signals. Moreover, the amount of data we receive through our senses is extremely limited in comparison to the actual electromagnetic spectrum. While we can see 100% of the visible spectrum, we see very little of the total electromagnetic spectrum. In fact, light visible to humans makes up just 0.0035% of the electromagnetic spectrum, with other animals able to see more than visible light. This limited perception of reality creates a paradox. How can we know what we are missing? The answer lies in scientific instruments that can detect and measure phenomena beyond our senses. For example, telescopes and microscopes can reveal worlds that are too small or too distant for our eyes to see, and spectrometers can detect wavelengths of light that are outside our visual range. In fact, our perception of reality is a highly personalized and constructed experience based on limited data. While our senses provide us with a wealth of information about the world, they also leave us with many unanswered questions. By using scientific instruments to extend our senses, we can begin to unravel the mysteries of the universe beyond our immediate perception. As scientists continue to explore the limits of human perception, they made a shocking discovery. After years of research and experimentation, they found that our brains are capable of perceiving more than we ever thought possible. By manipulating the electrical signals sent to the brain, they were able to expand our perception beyond the visible spectrum and into new realms of reality. The implications of this discovery were profound. Suddenly, the mysteries of the universe were no longer beyond our reach. With advanced technology and further research, we could explore new worlds and phenomena that were once invisible to us. However, this discovery also raised ethical questions. Should we tamper with our perception of reality? What are the risks of expanding our senses beyond their natural limits? As with any new technology, there were concerns about unintended consequences and unforeseen risks. Nevertheless, scientists pressed forward, driven by their curiosity and the desire to unlock the secrets of the universe. The future held both great promise and great peril, and it was up to us to navigate the unknown waters of expanded perception. Advances in technology, such as virtual and augmented reality, are already expanding our perception of reality and providing new avenues for exploration. For example, scientists are currently working on creating immersive virtual reality experiences that allow users to explore new worlds and phenomena. They are also developing augmented reality tools that can overlay digital information onto the physical world, enhancing our understanding of the environment around us. Furthermore, breakthroughs in imaging technology, such as hyperspectral imaging and terahertz imaging, are enabling us to see beyond what is visible to the naked eye. These tools are providing unprecedented insights into everything from the structure of molecules to the composition of distant planets. As we continue to push the boundaries of what we can perceive, we must also grapple with the ethical implications of expanding our senses beyond their natural limits. Sources have stated that advancements in nanobot technology is currently being used to enhance all senses to levels that are astonishing, literally, enabling the creation of what is essentially an actual superhuman. But one thing is clear: the discovery of our hidden potential is an exciting and inspiring development that promises to unlock new frontiers of exploration and understanding. References: 1. Eagleman, D.M. 2011. Incognito, The Secret Lives of the Brain. Random House Digital Incorporated. 2. Gregory R. L. 1970. The Intelligent Eye. Weidenfeld and Nicholson. 3. Hershenson, M. 1989. Visual Space Perception, a Primer. Oxford University Press. 4. How Stuff Works. 2023. How Human Vision Works. Retrieved from https://science.howstuffworks.com/live/human biology/human i4.htm. 5. International Dark Sky Association. Light Pollution and Its Effects on Wildlife. Retrieved from https://www.darksky.org/lightpollution/wildlife/.